Hi everyone. In this lesson, we are going to talk about measures of location in a dataset. Today, we are going to focus on where values are located within a dataset. We'll learn about quartiles, percentiles, interquartile range, often called the IQR, and outlier fences. Let's begin with quartiles. Quartiles divide an ordered data set into 4 equal parts. The word quartile comes from the word quarter, meaning 4 equal sections. Once the data are arranged from smallest to largest, quartiles help us understand how data are distributed. Let's imagine this is my data set and arrange from the smallest to the largest. These 3 numbers divide the data set into 1, 2, 3, 4 equal parts. These 3 numbers are my quartiles. Q1 is the first quartile. Q2 is the second quartile, which is also the median. Q3 is the third quartile. Q1 corresponds to the 25th percentile. That means about 25% of the data are at or below Q1. Q2, or the median, corresponds to the 50th percentile. That means about half of the data are at or below the median. Q3 corresponds to the 75th percentile. That means about 75% of the data are at or below Q3. To find the quartiles, we'll follow these 4 steps. First, put the data in order. Second, find the median or Q2. Third, find the median of the lower half, that is Q1. Fourth, find the median of the upper half, that is Q3. A common mistake is forgetting to sort the data first. Always arrange the data from least to greatest before finding quartiles. Example 1. Find Q1, Q2, and Q3 for this data set. Our first step is to arrange the data from least to greatest. First, we need to find the median. The median is the value right in the middle of the data set after we rearrange it from the least to the greatest. There are 13 values in this data set, so the median will be the 7th value. 1, 2, 3, 4, 5, 6, 7. The median is 66. The median splits the data into 2 halves. The first half has 6 values, and the second half has 6 values. Now let's find Q1. Q1 is the median of the lower half. There are 1, 2, 3, 4, 5, 6 values, so the median of the lower half is right here. Whenever we have an even number of values, the median is the average of the 2 middle values. So we need to find the average of 35 and 30. We take 30 plus 35 divided by 2. And that is 32.5. Now, let's find Q3. Q3 is the median of the upper half. Again, there are 6 values. Q3 is right here, which is the average of 79 and 80. So Q3 is 79 plus 80 divided by 2, which is 79.5. So our quartiles are Q1 is 32.5, Q2 is 66, and Q3 is 79.5. Notice that Q1, Q2, Q3 divide the order data into 4 sections. Each section contains approximately 1/4 of the observations. Now, let's talk about percentiles. A percentile tells us the percentage of observations that fall at or below a certain value. For example, imagine this is my data set arranged from the least to the greatest. The 80th percentile is right here. Approximately about 80% of the data are at or below this value, and about 20% of the data are above this value. Let's look at a couple of quick examples. 58th percentile means 58% of the data are at or below that value. Imagine this is my data set already arranged from the least to the greatest. 58th percentile is somewhere here, where 58% of the data are at or below that value, and 42% of the data are above that value. Now, for the 32nd percentile, if this is the data set already arranged from the least to the greatest, 32nd percentile is somewhere here, where I have 32% here and 68% here. So to complete this sentence, the 32nd percentile means what percent of the data are above that value. At the 32nd percentile, we have 32% below that value and 68% above that value. Example 2. A class has 300 exam scores. Question A, how many scores are at or below the 80th percentile? So imagine this is my data set already arranged from the least to the greatest. Let's locate the 80th percentile. 80th percentile has about 80% of the data are at or below that value. So if this is the 80th percentile, this is about 80% of the data, and this is about 20% of the data. So the question asks how many scores are at or below the 80th percentile. So I know that there's about 80% of the data are at or below the 80th percentile. To find how many scores, we take 80% of 300 scores. So we'll take 0.80 times 300. which equals 240. So there are approximately 240 scores are at or below the 80 percentile. So if your score is right here, there are about 240 scores are at or below your score, and about 60 scores are above your score. Now let's do part B. How many scores are above the 35th percentile? If this is my data set, arranged from the least to the greatest, 35th percentile is somewhere here. About 35% of the data are at or below the 35th percentile. About 65% of the data are above the 35th percentile. We want to find how many scores are above the 35th percentile. There are about 65% of the scores are above the 35th percentile. So we take 65% of 300, which is 0.65 times 300, which equals 195. Approximately 195 scores are above the 35th percentile. Interquartile range, or IQR, measures the spread of the middle 50% of the data. The formula is IQR equals Q3 minus Q1. Example 3. Let's calculate the interquartile range for this data set. To find the interquartile range, we need to find Q3 and Q1 first. We have already found Q1, Q2, Q3 for this data set from example 1, so we are going to reuse it. From example 1, Q1 is 32.5 and Q3 is 79.5. To find IQR, I use this formula. IQR equals Q3 minus Q1. Q3 is 79.5 and Q1 is 32.5. And 79.5 minus 32.5 is 47. So the IQR is 47. This means the middle 50% of the data spend 47 units. The IQR is useful because it is not strongly affected by unusually large or unusually small values.